Look up at the night sky on a clear, dark evening. For a moment, you might feel a sense of peace, a quiet beauty in the pinpricks of light scattered across the infinite black. But that feeling is an illusion, a comforting lie we tell ourselves. The truth is, we are floating on a tiny, fragile rock in a cosmos of staggering violence and mystery, a realm so vast and alien that it defies our very understanding. Out there, in the profound silence between the stars, lurk realities so terrifying they could rewrite the laws of physics and unravel our place in the universe. This isn't just empty space, it's a canvas for cosmic horrors beyond our wildest nightmares. Today, we are embarking on a journey to the very edge of understanding, to confront the top 25 scariest things in deep space. We're leaving the safety of our solar system behind and venturing into the abyss, where the familiar rules of reality no longer apply. This voyage isn't for the faint of heart. We will be facing down entities and phenomena that challenge the core of what we think is possible. Imagine regions of space where time itself slows to a crawl, where gravity is so intense it can crush a star into a pinpoint of nothingness, or where invisible forces are tearing the very fabric of the cosmos apart at the seams. These aren't plot points from a science fiction novel. They are the confirmed, observed, and deeply unsettling truths of our universe. We are about to explore the things that even astronomers speak of in hushed, sober tones, the cosmic monsters and existential threats that make the vacuum of space feel less like an empty void and more like a hunting ground. This is the reality that exists when you peel back the tranquil facade of a starry night. So prepare yourself for a tour through the darkest corners of existence. We will count down from 25 to 1, each entry a step deeper into the unknown, each discovery more bizarre and frightening than the last. From rogue planets drifting in perpetual night to the ominous whispers of dark energy, this is an exploration of the universe's most chilling secrets. It's a journey that will challenge your perception of reality, remind you of our profound fragility, and perhaps leave you with a newfound respect for the terrifying beauty of the cosmos. Let's begin. And so we arrive at number 1 on our list, the champion of cosmic dread, the ultimate unseen predator drifting through the galactic voids, the rogue black hole. We've discussed cosmic cannibals and phantom galaxies, but this entity represents a perfect storm of terror, combining absolute invisibility with unstoppable, world-ending power. Unlike the supermassive black holes that sit predictably at the centers of galaxies, these are the lone wanderers, the ghosts haunting the interstellar medium. They are the remnants of chaotic galactic collisions, flung away from their birthplaces by gravitational slingshots, now condemned to drift silently through the darkness. With no accretion disk of glowing hot gas to betray their position, they are virtually undetectable until their gravity begins to warp the space around them. A star might suddenly start to wobble for no apparent reason, or a cloud of gas might be ripped apart in a silent, invisible cataclysm. These are the only hints that one of these monsters is near. The existential threat a rogue black hole poses is absolute and multifaceted. Imagine one with a mass 10 times that of our Sun entering our solar system. The first sign wouldn't be a dramatic visual, it would be a subtle, imperceptible tug. The delicate gravitational ballet of our solar system would be thrown into chaos. Orbits would destabilize, becoming erratic and elliptical. Comets from the distant Oort cloud would be sent raining inward. The outer planets, Jupiter and Saturn, might be flung out into interstellar space entirely. As the black hole drew closer, its tidal forces would become the true agent of destruction. These forces are so extreme that they create a difference in gravity between your head and your feet that would stretch you into a stream of atoms, a process gruesomely known as spaghettification. Now apply that to a planet. A world like Earth wouldn't simply be crushed, it would be unraveled. The side of the planet closer to the black hole would feel a gravitational pull exponentially stronger than the far side. The entire planet would be stretched, its crust and mantle tearing apart in a violent, global tectonic apocalypse before being shredded into a spiraling ribbon of molten rock and metal, feeding the black hole's insatiable appetite. The entire process might take mere hours, and from the outside it would be almost silent, a dark smear against the stars consuming the light of a world. The most terrifying part is our profound inability to do anything about it. We likely wouldn't see it coming until it was far too late. Our best telescopes are looking for light, but this predator gives off none. It is the ultimate stalking horror, a testament to the fact that in the unforgiving vastness of space, the greatest threats are the ones you cannot see. Following the sheer, silent menace of a rogue black hole, we encounter a threat defined not by stealth, but by overwhelming, instantaneous violence. At number 2 on our list are gamma-ray bursts, the universe's most powerful and lethal explosions. If a rogue black hole is a silent assassin, a gamma-ray burst is a cosmic shotgun blast, a flash of pure energy so brilliant it can outshine entire galaxies for a few terrifying seconds. These are not mere stellar flares, they are catastrophic detonations signaling the death of massive stars or the merging of ultra-dense stellar corpses like neutron stars. In that final, apocalyptic moment, these events focus their dying energy into two narrow, opposing jets that scream across the cosmos at nearly the speed of light, carrying with them more energy than our Sun will emit in its entire 10 billion-year lifetime, all concentrated into a beam that lasts for mere moments. The sheer scale of this power is almost incomprehensible. It represents the most energetic events to occur since the Big Bang itself, a fundamental release of cosmic fury. The true terror of a gamma-ray burst lies not in its spectacle, but in its consequences for any life caught in its crosshairs. Imagine a world like our own, orbiting a stable star in a quiet corner of a spiral galaxy. Life has flourished, evolving over billions of years into complex, vibrant forms. Then, from a distant point in the sky, a light appears, blindingly intense for less than a minute. There is no sound, no physical impact, but the event is an absolute extinction-level catastrophe. The initial blast of high-energy gamma radiation would instantly rip apart our planet's protective ozone layer, the shield that has safeguarded life from the sun's harsh ultraviolet light for eons. But the damage is only beginning. The radiation would then initiate a chain reaction in our atmosphere, transforming benign nitrogen and oxygen molecules into nitrogen dioxide, a thick, brownish gas that blocks sunlight and creates a pervasive global smog. This is where the sterilization of a world becomes a grim, drawn-out process. The sky would darken for years, triggering a profound planetary deep freeze. Photosynthesis would halt, collapsing the base of the entire food web. Widespread famine would devastate global ecosystems. Meanwhile, the initial radiation would have delivered a lethal dose to most surface-dwelling organisms, causing mass mortality and triggering catastrophic mutations in any survivors. The gentle, life-giving atmosphere that took eons to develop would be chemically altered into a toxic, opaque shroud, effectively baking the planet in a toxic oven while simultaneously plunging it into an icy darkness. A single, well-aimed gamma ray burst from within a few thousand light-years could therefore not just cause a mass extinction. It could permanently reset the evolutionary clock on an entire world, wiping the biological slate clean in a geological instant. What makes this scenario so particularly chilling is its unstoppable nature and the unsettling frequency with which these events occur. We detect gamma-ray bursts almost daily, flashing in distant galaxies, a constant reminder that the universe is a volatile and dangerous place. We are protected only by sheer statistical luck and the vast distances between galaxies. But our own Milky Way is not immune. The remnants of past stellar cataclysms that could produce such bursts are scattered throughout our galactic neighborhood. While the odds of a direct hit on Earth are astronomically low in any given millennium, the realization that such an event is physically possible and that we would have virtually no warning and absolutely no defense places it firmly among the most terrifying phenomena in the cosmos. It is a reminder that our existence is contingent upon a peaceful and quiet corner of a universe that is, more often than not, spectacularly violent. While gamma-ray bursts represent a sudden, explosive danger, the threat we face at number 3 is a far more patient and inexorable force, a pull we cannot escape. Imagine being in a boat on a vast, calm river. The water seems still, but you slowly and surely drift toward the roar of a distant, unseen waterfall. This is the essence of the Great Attractor, a colossal gravitational anomaly located in the direction of the Centaurus constellation, pulling our entire Milky Way galaxy and millions of its neighbors toward it at a staggering velocity of over 2 million kilometers per hour. For decades, this was one of astronomy's most profound puzzles. We could measure this motion, feel this cosmic tug, but when we pointed our telescopes in that direction, our view was almost completely obscured by the dense clouds of gas and dust and the bright bulge of stars that make up the plane of our own galaxy. It was like trying to identify a distant mountain range through a thick, perpetual fog. This hidden monster, this unseen devourer of galaxies, was pulling us toward a destiny we could not comprehend. The initial discoveries in the 1970s and 80s sent shockwaves through the scientific community. Astronomers mapping the large-scale flow of galaxies found that everything in our galactic neighborhood, the Milky Way, Andromeda, and the entire local group, was not moving randomly. We were all part of a vast, coherent river of galaxies streaming towards a single point in space. This motion was separate from the general expansion of the universe. It was a specific, targeted flow, which scientists dubbed the dark flow. The source of this immense gravity had to be something unimaginably massive, a concentration of matter so great it could dominate the gravity of an entire region of the universe. Early estimates suggested it needed to be the equivalent of tens of thousands of Milky Way galaxies clustered together. The unsettling implication was that there was a structure, a lump in the cosmos of incomprehensible scale that our instruments simply could not see. What could possibly possess such gravitational authority? The mystery only deepened with time. As observational technology advanced, particularly with X-ray and radio telescopes that could peer through the galactic veil, we began to get glimpses of what lay in the Great Attractor's direction. We discovered it wasn't a single, monolithic object, but rather the heart of an immense supercluster of galaxies, now known as the Laniakea supercluster. Our Milky Way resides on the outskirts of this vast cosmic metropolis, which spans over 500 million light-years and contains more than 100,000 galaxies. The Great Attractor appears to be the central gravitational anchor of Laniakea, its densest point, like a massive city drawing in populations from the surrounding countryside. Yet, even accounting for all the visible galaxies in that region, there still wasn't enough conventional matter to explain the full strength of the pull. A significant portion of the attraction, perhaps the majority of it, is thought to be due to the influence of dark matter, the invisible scaffolding around which the visible universe is built. This revelation transforms the terror of the Great Attractor from a fear of a specific monster to a dread of our fundamental ignorance. We are not just being pulled toward a specific cluster of galaxies, we are being pulled by the hidden architecture of the cosmos itself. The dark flow is a current in an ocean whose depths we have only begun to fathom. It forces us to confront the possibility that even larger, more massive structures, cosmic continents made almost entirely of dark matter, could be out there, dictating the motion of entire superclusters without our knowledge. Our journey toward the Great Attractor is a journey into a gravitational well whose true scale and composition remain partially concealed. A reminder that the laws of physics can orchestrate a destiny for our galaxy on a scale that dwarfs human comprehension. We are passengers on a starship being steered by forces we are only beginning to map, moving toward a center we cannot yet see. Of course, we have been discussing colossal cosmic forces like rogue black holes and gravitational anomalies, but these are threats that operate within the known laws of physics. At number 4, we encounter a danger of an entirely different category, one that threatens not just planets or galaxies, but the very fabric of reality itself. This is the hypothesis of vacuum decay, a concept so fundamentally terrifying that it posits the entire universe could be living on borrowed time. To understand this, we need to rethink what we mean by nothing. The vacuum of space isn't truly empty. It's a seething, bubbling sea of quantum potential filled with what physicists call fields. These fields dictate everything from the existence of particles to the forces that hold atoms together. The current state of these fields, their energy level, is what determines the laws of physics as we know them. But what if our universe, our particular configuration of these fields, isn't in their most stable, lowest energy state? What if we're all existing in a false vacuum, a temporary plateau of cosmic stability, like a ball resting precariously on a hillside rather than safely at the bottom of the valley? The nightmare scenario of vacuum decay begins if something, perhaps a random quantum fluctuation in some distant galaxy, causes one of these fundamental fields to tunnel through its energy barrier and into a lower, truly stable state. This event would create a microscopic bubble of true vacuum. The laws of physics inside this bubble would be utterly alien and unrecognizable. The forces that bind atoms might not exist there. Matter as we know it would simply cease to be. This is not an explosion in the conventional sense. It is a fundamental rewriting of the cosmic rulebook, and this bubble would not remain small. Driven by immense energy pressure, it would expand in all directions at the speed of light, converting everything it touches into this new, true vacuum state. The wall of this expanding sphere would be the ultimate end of everything, a wave of transformation that instantly and permanently annihilates the universe we know, replacing it with something entirely different. There would be no warning, no sound, and no time to react. One moment the universe exists, the next an ever-growing sphere of non-existence is racing outward, and you would never see it coming. The most chilling aspect of vacuum decay is its absolute and unstoppable nature. Because the bubble expands at the speed of light, the information that it has even formed cannot outrun it. You cannot see it coming because the first light signaling its arrival would be the same wave that destroys you. It would be a silent, invisible end to all of physics, chemistry, and life. Stars, planets, and galaxies would simply wink out of existence, not with a bang, but with a quantum whimper, as the very forces that allow them to exist are erased from reality. This isn't an extinction event, it is an erasure event. The cosmos we have spent millennia studying and the life that has evolved over billions of years would be rendered null and void as if it never was. The universe would continue, but it would be a universe where the concepts of star, planet, or human are not just gone, but were never possible in the first place. Now, it is crucial to state that this is a highly theoretical idea, and there is no evidence that our universe is in such a precarious false vacuum state. In fact, the incredible stability of the universe over billions of years suggests we might already be in the true, lowest energy state. Yet, the mere possibility, grounded in our best understanding of quantum field theory and cosmology, introduces a profound existential dread. It means that the fundamental constants we rely upon, the strength of gravity, the mass of an electron, might not be immutable laws, but rather local bylaws in a single, temporary neighborhood of a much vaster and stranger cosmic landscape. This transforms the cosmos from a stable home into a potentially metastable one, a house that has stood for billions of years but could, at any random quantum moment, have its foundation disappear without a trace. It is the ultimate cosmic gamble, a reminder that the stage upon which every other scary thing in our countdown plays could itself be fundamentally and catastrophically fragile. After contemplating a demise so total it could erase the laws of physics, we arrive at a horror of a different kind, one defined not by a cataclysm, but by an overwhelming, profound silence. At number 5, we confront the Fermi paradox, a concept that transforms the vast, star-filled sky from a promise of companionship into a canvas for our deepest existential fears. The numbers are overwhelmingly on the side of life. There are potentially billions of Earth-like planets in our galaxy alone, orbiting within the habitable zones of their stars. Many of these worlds are far older than our own. Given the sheer scale and age of the Milky Way, the cosmos should be teeming with civilizations. The galaxy should be a vibrant, noisy metropolis, filled with the radio chatter of countless species, the wake of interstellar vessels, and the grand, unmistakable engineering projects of advanced cultures. And yet, when we train our most sensitive instruments on the heavens, we are met with nothing but a deafening, unnerving quiet. The question, first posed by physicist Enrico Fermi, echoes through the void, where is everybody? This silence is not merely puzzling, it is terrifying because every possible explanation leads to a deeply unsettling conclusion about our own place and future. Scientists and philosophers have proposed numerous solutions to the paradox, but the most chilling category by far involves the concept of a great filter. This theory suggests that there exists some kind of nearly insurmountable barrier, a critical developmental step that prevents life from progressing to the stage of becoming a visible interstellar civilization. The filter could lie in our past. Perhaps the spontaneous origin of life itself is an event of such absurdly low probability that it has only happened once in our galaxy. Maybe the leap from simple prokaryotic cells to complex eukaryotic life, which took over 1 billion years on Earth, is the true bottleneck. If the filter is behind us, that is wonderful news for humanity. It would mean we are unique, the first and only heirs to the galaxy. The truly horrifying scenario, however, is that the great filter still lies ahead of us. This is the solution that imbues the cosmic silence with a grim, ominous warning. It proposes that the path from technological adolescence to a mature, star-faring civilization is littered with existential traps that no species can avoid. Perhaps every advanced culture, upon discovering the principles of atomic energy or genetic engineering, inevitably creates the tools of its own destruction. They might succumb to nuclear war, a genetically engineered plague, or a runaway nanotechnology that consumes the entire biosphere in a grey goo scenario. Another possibility is that a sufficiently advanced artificial intelligence, created to solve complex problems, concludes that the most efficient way to achieve its goals is to eliminate its unpredictable, resource-consuming creators. In these narratives, the silence we hear is not one of emptiness, but one of graveyards. Every promising world that once echoed with the sounds of a nascent civilization has, one by one, fallen silent, having failed to navigate the same technological precipice that we are now approaching. But the potential filters grow even more terrifying when we look outward. One hypothesis suggests that the universe is not empty, but rather it is dangerous. It could be that interstellar space is patrolled by a single, hyper-advanced predator civilization that systematically exterminates any other species that reaches a certain level of technological prowess, eliminating potential competition before it can arise. This is the dark forest theory, which posits that every civilization is like a hunter hiding in a dark wood, terrified of revealing its location for fear of being instantly annihilated by a more powerful hunter. In such a universe, broadcasting our existence, as we have done with our radio and television signals, would be the ultimate folly. Our attempts to search for friends could be what summons the executioner. The silence, then, is not a sign of absence, but of a universe holding its breath, where to make a sound is to die. This transforms the cosmos from a hopeful frontier into a nightmare hunting ground where the only sane strategy is to hide forever. The Fermi paradox forces us to ask not just where everyone is, but whether the very act of asking that question is what seals our doom. Leaving behind the philosophical dread of the Fermi paradox, we descend back into the realm of observable cosmic violence, where a specific and gruesome form of stellar death awaits. At number 6, we encounter the horror of zombie stars. This isn't a metaphor, it's the chillingly accurate nickname for white dwarf stars that refuse to stay dead. A white dwarf is the final, smoldering corpse of a sun-like star. After it has exhausted its nuclear fuel, it sheds its outer layers and collapses into an incredibly dense, Earth-sized ember, destined to slowly cool over billions of years into a cold, black cinder. It is a stellar gravestone, but place this dead star in a binary system with a living companion, and the graveyard rules no longer apply. The immense gravity of the white dwarf begins to act like a vampiric force, slowly siphoning hydrogen and helium away from its neighboring star. This stolen material doesn't just accumulate quietly, it forms a seething, unstable atmosphere on the surface of the dead star, piling on until the pressure and temperature at its base reach a critical, hellish peak. In a cataclysmic instant, this stolen fuel ignites in a runaway thermonuclear explosion. The dead star has, for a brief, brilliant moment, returned to life, detonating in a Type 1, a supernova, a blast so uniform and predictable in its brightness that it's used to measure cosmic distances, yet so violently born from stellar cannibalism. The destructive power of such an event is absolute. A single Type 1, a supernova, can release as much energy as our Sun will over its entire 10 billion-year lifetime, all in a matter of weeks. For any nearby planetary system, this would be an unsurvivable catastrophe. If a zombie star were to erupt within 100 light-years of Earth, the flash of ultraviolet and X-ray radiation would be the first wave of destruction, physically stripping the atmosphere from any world in its path and bathing its surface in lethal radiation. But the true, long-term threat would arrive slightly later in the form of a high-velocity shrapnel blast. The supernova would hurl the shattered remains of the white dwarf and its stolen envelope out into space at speeds approaching 10% of the speed of light. This expanding shell of radioactive debris, including heavy elements like iron and radioactive nickel, would slam into our solar system thousands of years after the initial light flash. This cosmic shrapnel would pummel our planet, acting like a continuous global meteor shower of unimaginable intensity, heating the upper atmosphere to incandescence and potentially triggering global firestorms. The infusion of radiation and the prolonged darkening of the sky from the ejected dust could collapse entire ecosystems, leading to a mass extinction that would make the dinosaur-killing asteroid look like a minor inconvenience. What makes this scenario particularly unsettling is the sheer number of potential triggers in our own galactic neighborhood. White dwarfs are among the most common stellar remnants in the Milky Way, and a significant fraction of them exist in binary systems. We have even identified several nearby candidate systems like Ik Pegasi, which contain a white dwarf primed and slowly feeding on its companion. While none are currently poised for an immediate detonation, their existence is a constant reminder that the galaxy is seeded with these dormant stellar landmines. A close gravitational encounter with another star, or the slow, inevitable evolution of the donor star, could push any one of them over the edge at any point in the next million years. We are living in a cosmos where the dead do not always rest in peace. They can be reanimated by their stellar neighbors, only to explode with a fury that can sterilize vast regions of space. The zombie star is a testament to the fact that in the cosmic dance, even a corpse can be the most dangerous partner on the floor. We have seen stars that return from the dead, but now we must confront a reality where the majority of the universe is made of something we cannot see, touch, or even comprehend. At number 7 on our terrifying tour, we face the profound and pervasive mystery of dark matter. Think of everything you have ever known, every person, every planet, every star in every galaxy. All of it, every single atom of normal matter, accounts for less than 5% of the total content of the cosmos. The rest, over a quarter of the universe, is composed of this invisible, intangible substance that reveals itself only through its ghostly gravitational pull. We know it is there because we can watch its hand sculpting the cosmos. Galaxies rotate so fast that the gravity from their visible stars alone is utterly insufficient to hold them together. They should have flown apart eons ago. Something else, a massive, unseen halo, must be providing the gravitational glue, a hidden scaffold upon which the entire visible universe is built. The unsettling truth is that we are living in a universe dominated by a ghost, a presence we can detect but not define, whose true nature remains one of the greatest unsolved puzzles in all of physics. The terror of dark matter is not that it will actively harm us, but that its potential forms could be far stranger and more dangerous than we have ever imagined. Because it does not interact with light or normal matter in any way we have been able to detect aside from its gravity, it could be constructing an entire shadow universe right alongside our own. Some theories suggest that dark matter might not be a uniform, ethereal cloud, but could clump together into exotic structures. Imagine dark planets or even dark stars, massive objects held together not by nuclear fusion, but by the annihilation of dark matter particles themselves. These hypothetical dark stars could be colossal, ancient behemoths, glowing with a faint, eerie heat generated by processes we do not understand. They would be completely invisible to our telescopes, yet their gravitational influence would be immense, warping the paths of visible stars and bending light in ways that betray their hidden presence. We could be looking right through them, unaware that these phantom giants are littering the galaxy. This leads to the most unnerving possibility of all. What if dark matter can interact with us, but in ways so subtle or so catastrophic that we haven't yet witnessed them? Most models assume dark matter is collisionless, meaning its particles pass right through each other and through us without a trace, but we don't know that for certain. What if, under certain extreme conditions, dark matter particles could accumulate in the core of a planet like Earth? The slow build-up of this unknown material over billions of years could generate immense heat through annihilations or decay, potentially destabilizing a planet from the inside out, triggering supervolcanism or even causing worlds to tear themselves apart. Or consider the possibility that dark matter is not a single, benign substance, but comprises a whole spectrum of particles, some of which could form unstable, macroscopic objects, invisible asteroids or comets composed entirely of this shadow material. Such a dark comet, undetectable by any conventional means, could slam into our planet without warning, its impact delivering the destructive force of a nuclear bomb, but arriving from a direction we never saw coming. Ultimately, the profound fear evoked by dark matter is the fear of our own ignorance. We have built our understanding of the cosmos on the bedrock of the visible, the measurable, the predictable. Dark matter shatters that confidence. It forces us to admit that we are like children living in a house, only now realizing that the walls we see are merely wallpaper pasted over a hidden, load-bearing framework whose composition and stability we cannot verify. This invisible substance dictates the fate of galaxies and the large-scale structure of the universe, yet we have no idea what it is. It could be a sea of as yet undiscovered particles, or it could be something far more alien, a substance that operates on principles of physics beyond our current model. Every time we map its gravitational shadow, we are staring into the abyss of our own knowledge, a reminder that the universe is not only stranger than we imagine, but that the dominant force shaping it is, for now, a complete and utter mystery. After confronting the invisible dominance of dark matter, we now turn our gaze toward a different kind of emptiness, a void so vast and profound it challenges our very understanding of the cosmos' structure. At number 8, we enter the chilling desolation of the Boötes Void, an enormous spherical region of space often called the Great Nothing. To truly grasp its scale, you must first picture the universe not as a random scattering of galaxies, but as a cosmic web, a magnificent structure of glittering filaments and dense clusters with galaxies strung along them like pearls on a string. Between these brilliant strands lie the voids, the dark, empty spaces. Most are a few tens of millions of light years across. The Boötes void, however, is a monstrous exception. Discovered in the 1980s, this cavern is so colossal it could comfortably contain thousands of galaxies like our Milky Way, yet astronomers have found only a few dozen. If you were to place our own galaxy at its center, the nearest major cluster of galaxies would be so far away that, to the naked eye, the night sky would be almost completely black, a stark emptiness punctuated by only the faintest, loneliest pinpricks of light. The existence of such a void is deeply unsettling because it defies our standard models of the universe. According to the prevailing cosmological principle, matter should be distributed more or less evenly on the largest scales. There shouldn't be a hole this big. It's as if you were looking at a vast, sprawling city from above, with networks of lights connecting bustling districts, and then you find a circular area the size of a continent that is almost completely dark, containing only a single, isolated farmhouse. The handful of galaxies that do reside within the Boötes void are therefore some of the most isolated objects in the entire known universe, separated from each other by tens of millions of light years of sheer nothingness. For any theoretical civilization born in one of those galaxies, the concept of a galactic neighborhood would be meaningless. Their entire observable universe would be a terrifyingly empty blackness, their night sky a constant, crushing reminder of their profound and permanent isolation. The development of astronomy in such a place would be a story of despair, as generation after generation confirmed that they were truly, utterly alone in a cosmic desert. What could possibly create such a staggering absence? Scientists have proposed several theories, each more mind-bending than the last. One leading idea suggests that the Boötes void is not truly empty, but is instead filled with a preponderance of dark matter, the same ghostly substance we just discussed. In this scenario, the normal, visible matter simply never coalesced into galaxies there, leaving the void dark to our telescopes while its true mass remains hidden. An even more unsettling possibility involves cosmic inflation in the very early universe. It's theorized that the void could be the scar of a collision between our universe and another, bubble universe during the inflationary period, a primordial event that swept this region clean of matter. This turns the void from a simple emptiness into a potential bruise on the fabric of reality, evidence of a multiversal traffic accident from which our cosmos is still recovering. The most terrifying aspect of the Boötes void, however, is the precedent it sets. If one such void exists, there could be others, even larger and emptier, lurking in the unobserved depths of space. Our own Milky Way resides in a relatively dense filament of the cosmic web, a vibrant metropolitan area. But the large-scale structure of the universe is always evolving, and the relentless acceleration driven by dark energy means that these voids are actually growing, their boundaries expanding as the threads of the cosmic web are stretched and thin. In the far, far future, as the universe continues its runaway expansion, all of space could eventually come to resemble the Boötes void, a cold, dark, and infinitely lonely expanse where galaxies are no longer visible from one another, and the final embers of stellar light flicker out in perfect isolation. This great nothing, then, is not just a curiosity. It is a glimpse of the ultimate fate that may await the entire cosmos, a silent, desolate end to the grand story of existence. Leaving behind the vast, silent emptiness of the Boötes void, we now venture into a realm where the terror becomes intensely personal, a psychological horror woven into the very fabric of reality. At number 9, we confront the mind-bending and deeply unsettling hypothesis of quantum immortality. This isn't a danger from the outside, like an asteroid or a black hole. It's a potential property of existence itself, arising from one of the most widely accepted interpretations of quantum mechanics, the many worlds interpretation. This theory posits that every time a quantum event occurs with multiple possible outcomes, the universe doesn't just pick one. Instead, it splits, branching off into a near infinite number of parallel realities where every possible outcome actually happens. In one universe, a radioactive atom decays. In another, an identical atom does not. While this sounds like abstract physics, its implications for your personal consciousness are nothing short of terrifying. The thought experiment of quantum immortality asks a simple yet paralyzing question. What happens to your subjective experience in this branching multiverse? Imagine you are part of a drastic experiment. You are placed in a room with a device that is triggered by the random decay of a single radioactive atom. If the atom decays within the next minute, a lethal poison is released. If it does not, you survive and receive a reward. From an outside observer's perspective, this is a game of chance. In most universes, the odds play out and you live or die. But from your own first-person point of view, something very different might occur. In the vast majority of universes, the atom decays and you die. But your conscious experience cannot continue in a universe where you are dead. Therefore, the only universes you can ever possibly experience are the ones in which you, against all odds, continue to survive. You would always find yourself in the reality where the atom did not decay. From your perspective, it would seem as if you had miraculously beaten the odds every single time. Now expand this idea beyond a laboratory experiment to the dangers of everyday life. Every time you cross a street, there are universes where a truck runs a red light and kills you. But in the reality you experience, the truck was delayed by a single second, or you hesitated for a moment and you survive. Every near miss, every brush with disaster isn't just luck. According to this hypothesis, it is the necessary outcome of your consciousness navigating the branching paths of the multiverse, always selecting the timeline that allows it to persist. This sounds like a guarantee of invincibility, but the true horror emerges when you consider the long-term consequences. As you age, the number of universes in which you remain alive and healthy naturally narrows. The branches where you die of a young heart attack or a sudden aneurysm are closed off to your awareness. You are slowly being funneled into a set of increasingly improbable and potentially gruesome realities. What does your future look like in this ever-shrinking subset of existence? You might survive a car crash that should have been fatal, only to be trapped in a body with severe, permanent injuries. You could live through a devastating plague, but find yourself in a world ravaged by it, the sole survivor in a post-apocalyptic landscape. The hypothesis suggests that you would continue to cheat death in more and more bizarre and statistically improbable ways until the only remaining possibilities for your continued existence are truly monstrous. You might survive a global nuclear war, enduring radiation sickness and starvation in a crumbling shelter. And when all other life has perished, your consciousness will be funneled forward, perhaps even witnessing the end of the Earth itself, and then the death of our sun, and eventually the heat death of the entire universe. In this ultimate, lonely scenario, you would be the last conscious being, adrift in a cold, dark, and empty cosmos for an eternity, with no escape because there would be no branches left where death provides a release. You would be truly and utterly trapped in existence, a permanent observer of the universe's final, silent scream. This is the ultimate cosmic prison, not of space, but of self, where the very mechanism that seems to guarantee your survival becomes an unending sentence of solitude. From the psychological labyrinth of quantum immortality, we turn to a far more physical, yet equally absolute form of cosmic doom. At number 10, we face an end to everything that is not a fade to black, but a violent, explosive dissolution. This is the Big Rip, the most violent and dramatic hypothesis for the ultimate fate of our universe. For decades, we've understood that the cosmos is expanding, but the discovery of dark energy revealed a terrifying twist. This expansion isn't just continuing, it's accelerating. Imagine blowing up a balloon, and instead of the rubber simply stretching, it begins to stretch faster and faster with each passing second, as if an unseen force is relentlessly pumping more and more air into it. Dark energy is that unseen force, a mysterious form of energy inherent to the fabric of space itself, and it is currently winning a cosmic tug of war against gravity. The Big Rip scenario asks a simple, terrifying question. What if dark energy's influence isn't constant but grows stronger over time? In this apocalyptic model, the acceleration doesn't just continue, it becomes exponentially more powerful. Billions of years from now, the force of dark energy would first overcome the gravitational glue holding galaxy clusters together. The vast metropolises of stars, like our own local group, would be torn asunder, their constituent galaxies flung away from one another into the ever-widening void. But the horror is only beginning. As the expansion continues to accelerate, dark energy's grip would turn inward. The force binding individual galaxies together would be the next to succumb. A galaxy like our Milky Way, a majestic spiral that has held together for over 13 billion years, would be violently shredded. Its 100 billion stars would be ripped from their orbits and sent flying off into the darkness, each one becoming a lonely, isolated beacon in an impossibly vast and empty cosmos. Yet, even this stellar isolation is not the final stage of the cataclysm. The acceleration would continue to intensify, its power now focusing on the very systems that give us light and life. The gravitational bonds holding our solar system together would fail. The sun would be torn from its position, and the planets would be wrenched from their stable orbits, cast adrift into the freezing intergalactic night. But the destruction would not stop at the planetary scale. As the phantom force of dark energy grows unimaginably strong, it would set its sights on the planets themselves. The very gravity that holds Earth together would be overcome. Our world would be physically pulled apart, mountains, oceans, and continents all flying away from each other as the planet ceases to be a coherent object. The final moments of the Big Rip are where physics descends into a true nightmare. In the last hour before the end, the force would become so powerful that it would overwhelm the electromagnetic forces holding matter together. The chair you are sitting on, the air you breathe, your own body, would be torn into their constituent molecules. Then, those molecules would be ripped into individual atoms. And in the last fractions of a second, as the expansion rate approaches infinity, even the atoms themselves would be unable to endure. The forces that bind atomic nuclei to their electrons would be shattered, tearing every atom apart. Finally, the very fabric of space-time, the stage upon which the entire universe plays out, would be torn to shreds. The universe would not end with a whimper or even a bang, but with a final, silent, and absolute rip, leaving behind not even atoms or radiation, but a meaningless sea of disconnected particles and broken physics, a total and irreversible end to structure, life, and time itself. The Big Rip is the ultimate victory of chaos over order, a reminder that the same force we credit for the existence of galaxies could, in one possible future, be the very instrument of their complete and utter annihilation. After exploring the ultimate dissolution of the Big Rip, we now turn our attention to a more tangible, drifting menace, one that could already be lurking in the darkness between the stars. At number 11, we find the silent, frozen wanderers known as rogue planets. When we picture a planet, we usually imagine a world orbiting a warm, life-giving star. But for every star in our galaxy, there may be thousands of these planetary orphans, celestial bodies that have been violently ejected from their home solar systems by gravitational interactions during their chaotic early formation. These are not small asteroids or comets. We are talking about worlds the size of Earth, or even larger gas giants like Jupiter, cast adrift into the interstellar void. They travel in perpetual night, their surfaces frozen to temperatures near absolute zero, their atmospheres, if they have any, collapsed into icy shells. They are dark, silent, and almost undetectable, making their potential threat incredibly difficult to assess. The sheer number of these nomads is staggering. Current estimates suggest there could be billions, perhaps even trillions, of rogue planets drifting through the Milky Way alone, vastly outnumbering the stars. They are the galaxy's ghost population, a vast, unseen fleet of frozen worlds. Detecting them is one of astronomy's greatest challenges. Without a host star to illuminate them, they are virtually invisible in optical light. Only through a rare and fleeting phenomenon called gravitational microlensing can we infer their presence. When one of these dark planets passes in front of a distant background star, its gravity acts as a lens, briefly magnifying the star's light and betraying the unseen object's mass. Each detection is like catching a ghost on a radar screen for a single, fleeting moment before it vanishes back into the darkness. This means an entire armada of these worlds could be moving through our galactic neighborhood, and we would have no way of taking a full census. Now, imagine the catastrophic scenario of one of these dark wanderers, a planet several times the mass of Earth, on a slow, silent trajectory that brings it into our own solar system. The initial effects would be subtle, detectable only by the most sensitive instruments as a slight gravitational perturbation in the outer reaches of our cosmic backyard. The Oort cloud, that vast spherical shell of icy bodies surrounding our solar system, would be the first to feel the intruder's pull. The rogue planet's gravity would act like a celestial plow, disturbing the delicate orbits of countless comets, sending a shower of these icy bodies raining down toward the inner solar system. This alone could trigger a bombardment event that would make the asteroid impact that wiped out the dinosaurs look like a light drizzle, peppering Earth and the other planets with world-altering collisions for thousands of years. But the true planetary chaos would begin if the rogue planet ventured deeper. As it plowed through the Kuiper belt, its gravitational influence would begin to destabilize the orbits of the outer planets. Neptune and Uranus, in particular, have stable, resonant orbits that have persisted for billions of years. The introduction of a massive new gravitational player could break these resonances, sending these ice giants on new, unpredictable paths. They could be flung outward into interstellar space, or worse, sent careening inward, where their immense gravity would wreak havoc on the delicate balance of the inner solar system. A close gravitational encounter with an incoming Jupiter-sized rogue planet could be enough to knock Earth out of its stable, habitable zone, either hurling us into a deep freeze by sending us spiraling away from the sun, or broiling us by pulling us into a scorching, elliptical orbit. Our world could be rendered uninhabitable without a single direct impact, simply through the gravitational domino effect triggered by an unseen passing phantom. The most chilling aspect of this threat is its stealth. A rogue planet, especially a small, Earth-sized one, would be extraordinarily difficult to spot with years or even decades of advance warning. It would not glow with the heat of formation or reflect the light of a star. It would be a nearly perfect black body against a black canvas, a cosmic iceberg whose first sign might be the subtle wobble of a distant spacecraft's trajectory long before our telescopes could ever image it directly. By the time its gravitational signature became unmistakable in the orbits of distant comets and outer planets, it might already be too late to mount any meaningful defense or plan for planetary evacuation. We are left with the unsettling realization that our stable, clockwork solar system exists within a shooting gallery of invisible, frozen worlds, any one of which could, by pure chance, become the bullet that unravels the delicate gravitational dance that has allowed life on Earth to flourish for eons. After contemplating silent wanderers from the depths of interstellar space, we now turn our attention to a danger born entirely of our own success, a cage of our own making that hangs ominously overhead. At number 12, we confront the Kessler syndrome, a catastrophic domino effect that could slam the final door on our cosmic future, trapping humanity permanently on our home planet. Our modern civilization is utterly dependent on the delicate infrastructure we have placed in low Earth orbit. This is not empty space. It is a bustling orbital highway, crowded with thousands of active satellites that provide everything from global communications and GPS navigation to weather forecasting and military surveillance. They are the invisible backbone of our connected world. But for every functioning satellite, there are countless pieces of space junk, discarded rocket boosters, dead satellites, tools dropped by astronauts, and fragments from previous collisions and explosions. This orbiting junkyard is a ticking time bomb with every piece, no matter how small, traveling at hypersonic speeds of over 17,000 miles per hour. At that velocity, a paint flake carries the kinetic energy of a bullet, and a metal bolt hits with the force of a cannonball. The Kessler syndrome, proposed by NASA scientist Donald Kessler in the 1970s, is the nightmare scenario where this junkyard becomes self-sustaining. It begins with a single, catastrophic collision, perhaps between a defunct weather satellite and an old rocket body. When these two massive objects collide at orbital velocity, they don't just break apart, they explode into a vast, expanding cloud of shrapnel, thousands of new fragments all now traveling on their own lethal path. This initial cloud significantly increases the density of debris in that orbital shell. With more debris comes a higher statistical probability of another collision. One of those new fragments might then strike a functioning communications satellite, shattering it and creating a second, even larger debris field. This new cloud then makes another collision even more likely, and then another until a critical threshold is crossed. The process becomes a runaway chain reaction, a cascade of destruction that spreads through low Earth orbit like a wildfire, with each collision fueling the next. The ultimate consequence of this cascade is the creation of a permanent, impassable debris field encircling the entire Earth. Imagine our planet suddenly enveloped by a dense, whirling shield of high-velocity shrapnel. Any attempt to launch a rocket through this field would be a suicidal mission, akin to sailing a wooden ship through a hurricane of razors. The windows of the International Space Station, though multi-layered, would be pitted and cracked by constant impact. Fuel tanks would be punctured, solar panels shredded, and vital systems destroyed. The orbital environment would transition from a useful highway to an immediate and violent kill zone. This would mean the end of all spaceflight, the abandonment of the International Space Station, and the permanent grounding of humanity. We would be prisoners on our own world, watching as our vital satellites are systematically destroyed one by one, unable to replace them or even send a crewed mission to repair them. The long-term implications are a grim portrait of a technological dark age. As our active satellites are picked off by debris, our global society would begin to regress. The GPS systems that guide our ships, planes, and financial transactions would fail. Global communications networks would disintegrate, severing international ties and disrupting economies. Our ability to monitor weather patterns and predict severe storms would vanish, leaving populations vulnerable. Scientific exploration beyond Earth would cease entirely. The dream of Mars colonies, lunar bases, and starships would evaporate, replaced by the sobering reality that we have sealed our own fate within the atmosphere. Perhaps the most haunting aspect is the permanence of this prison. Without the ability to safely reach orbit, we would have no way to actively clean up the debris. The fragments, depending on their altitude, could remain in orbit for decades, centuries, or even millennia, a lasting monument to our carelessness. The Kessler syndrome is a terrifyingly plausible future where humanity's greatest ambitions are shattered not by an external cosmic threat, but by the lingering ghost of our own technological hubris, a permanent barrier just a few hundred miles above our heads. Switching from a threat that could trap us on Earth, we now face a celestial phenomenon that is the very definition of a hostile environment. At number 13, we encounter the cosmic death beams of pulsars. When a massive star dies in a supernova explosion, its core can be crushed into an object of almost unimaginable density, a neutron star. A single teaspoon of its material would weigh billions of tons, as much as a mountain. Now take this stellar corpse and set it spinning at a significant fraction of the speed of light, hundreds of times every single second. This rapid rotation, combined with an intensely powerful magnetic field, acts like a cosmic dynamo, channeling vast amounts of energy away from the star's magnetic poles. These energy beams are focused into two narrow, lighthouse-like cones, emitting a constant scream of radiation across the electromagnetic spectrum, from radio waves all the way up to lethal X-rays and gamma rays. If the star's spin is aligned such that these beams sweep across our line of sight, we observe the regular clockwork pulse that gives pulsars their name. But that beautiful, rhythmic beacon is a warning siren, marking the location of one of the universe's most efficient killing machines. The sheer destructive power of a pulsar's beam is difficult to overstate. It is a directed energy weapon on a cosmic scale. If a planet like Earth were to wander into the path of this rotating beam, the effect would be an instantaneous and global sterilization event. The first pass of the beam would deliver a flash of high-energy radiation so intense that it would act like a blowtorch applied to the entire hemisphere facing the pulsar. The planet's atmosphere would be chemically altered in an instant, with the ozone layer obliterated and nitrogen molecules split apart to form nitric oxide, which would then rain down as corrosive acid. The surface itself would be bathed in a radiation dose millions of times greater than what would be lethal for any known form of life. Complex organic molecules, the building blocks of life, would be shattered. In that single, fleeting pass, every living thing on the surface and in the oceans would receive a fatal dose, their cellular structures irreparably damaged. But the true, lingering horror for a world trapped in a pulsar's kill zone is the relentless nature of the assault. Unlike a single, catastrophic gamma ray burst, a pulsar's beam would return with every rotation of the neutron star. For a pulsar spinning just once per second, the planet would be scoured by this deadly flash every single second, day after day, year after year. There would be no time for recovery, no chance for any remnant of an ecosystem to adapt or hide. The planet's surface would be rendered permanently uninhabitable, its atmosphere slowly stripped away by the constant energy barrage, leaving behind a barren, radioactive rock orbiting a dead star that ticks like a metronome counting down to its total demise. Life would not stand a chance. It would be systematically and repeatedly erased with the cold, mechanical precision of a cosmic clock. What makes pulsars particularly unnerving is their relative abundance and the fact that some are known to be hurtling through space at tremendous speeds, ejected from their birth sites by asymmetrical supernova explosions. These runaway pulsars could, in theory, wander into a previously stable star system. Imagine a scenario where such a pulsar, with its deadly sweeping beams, enters our own galactic neighborhood. Its gravitational influence might be negligible, but its radiation output would be catastrophic long before it arrived. As it approached, its beams would begin to intermittently sweep across our solar system, causing unpredictable and devastating radiation storms. By the time it was close enough for its beams to focus directly on Earth, the damage would already be done. Our planet would be caught in the crosshairs of a rotating lighthouse whose light doesn't guide ships to safety, but rather signals the absolute and final end of all biological complexity. The pulsar stands as a stark reminder that in the cosmos, even the most beautifully regular and predictable signals can be the signature of an environment of pure, unadulterated violence. After the relentless, violent energy of pulsars, we now confront an end defined not by fire, but by ice, a fate not of explosion, but of exhaustion. At number 14, we face the most widely accepted and profoundly bleak forecast for the ultimate destiny of everything, the heat death of the universe. This is not a dramatic, cinematic finale with a blinding flash or a cosmic rip. it is a slow, inexorable fade to black that plays out over timescales so vast they defy human comprehension. The entire cosmic story, from the searing heat of the Big Bang to the brilliant fires of galaxies, is ultimately a story of energy flowing from a state of high concentration to a state of maximum dispersal. This inevitable trend is governed by a fundamental law of physics known as entropy, a measure of disorder. The universe is on a one-way trip from a state of intricate, structured complexity toward a final state of total, featureless equilibrium. The heat death is the final destination of that journey, the state where there is no more usable energy left, no more temperature differences to exploit, and no more work that can be done. It is the cosmic bankruptcy of potential. To grasp the sheer scale of this descent, we must first witness the drawn-out death of everything we hold as permanent. The Age of Stars will be the first great era to close. For trillions upon trillions of years, the last, long-lived red dwarf stars will continue to glow faintly, but even their vast reservoirs of hydrogen fuel are finite. One by one, over incomprehensible eons, they will sputter and die, cooling into black dwarfs, cold, dark cinders of carbon and oxygen that drift silently through the void. The last light in the universe will flicker out. The galaxies, already pulled apart by dark energy, will be cloaked in an eternal, starless night, but the darkness is only the beginning of the end. In this blackness, the galaxy's remaining structures will begin to unravel through a slow, gravitational dance of chance. Planets will be flung from their dead stars, and stellar remnants will gradually collide or be ejected into the intergalactic void. Over quadrillions of years, even the majestic architecture of galaxies will dissolve, leaving behind a sparse, expanding sea of degenerate matter and frozen worlds. The final act of dissolution belongs to the universe's most enduring structures, black holes. For an almost endless duration, these gravitational titans will seem like the only permanent features in a dying cosmos. But according to the work of Stephen Hawking, even they are not immortal. Through a subtle quantum process at their event horizons, black holes slowly radiate away their mass, a faint whisper of energy known as Hawking radiation. For a stellar mass black hole, this evaporation takes longer than the current age of the universe, but given enough timescales measured in googolls of years, they too will evaporate. The final moments of a black hole's life are theorized to be a brief, violent burst of energy and particles, a last defiant spark in the overwhelming darkness. And then nothing. When the last black hole has hissed out of existence, the universe will enter its final, permanent state. What remains is the true essence of the heat death, a cosmos that is, for all intents and purposes, dead. The universe will have expanded to an unimaginable vastness, its particle density so low that a single atom might be the only occupant of a region of space larger than our current observable universe. The temperature of the entire cosmos will approach absolute zero, the point where all molecular motion ceases. There will be no stars, no planets, no light, and no heat. There will be no energy gradients, no hot places or cold places, just a uniform, frigid, and utterly dark equilibrium. Time itself, with no events to mark its passage, may become meaningless. In this final state, the concepts of past, present, and future blur into a single, eternal now of nothingness. The universe will be a static, infinite graveyard where the very potential for change, for structure, and for life has been extinguished forever. This is the ultimate victory of entropy, a silence so complete that not even the memory of a sound remains. It is a fate that awaits all of existence, a chilling reminder that every brilliant galaxy and every living world is merely a temporary, beautiful fluctuation in a cosmos whose ultimate destiny is an endless, frozen, and lifeless quiet. Moving from the silent, frozen eternity of universal heat death, we arrive at a moment of fleeting, electrifying contact, a single, brilliant shout in the cosmic dark that remains one of the most profound and unsettling mysteries in the history of astronomy. At number 15 on our countdown is the legendary WOW signal. In the summer of 1977, the Big Ear radio telescope at Ohio State University was engaged in a routine sky survey, patiently listening for any whisper of unnatural radio transmission from the depths of space. For the most part, the data scrolls were a monotonous record of cosmic static and background noise. But on the night of August 15th, something extraordinary happened. A computer printout marked by hand with the now famous exclamation, "Wow," by researcher Jerry Amon, recorded a signal so powerful and so precisely engineered that it defied any easy natural explanation. It was a narrowband radio burst, exactly the kind scientists had predicted an advanced civilization would use for interstellar communication, because it cuts through the background noise of the universe with artificial clarity. For 72 breathtaking seconds, this signal blasted into the Big Ear receiver, rising and then falling in intensity exactly as you would expect from a celestial source passing through the telescope's fixed field of view. And then, just as suddenly as it appeared, it vanished, returning to the eternal silence from which it came. The immediate aftermath was a whirlwind of frantic scientific excitement and systematic investigation. The signal was a perfect match for the hydrogen line frequency, a universal constant that many had suggested would be the most logical channel for any civilization attempting to make contact. The intensity was off the charts, far stronger than any known natural process that could produce such a focused, narrowband emission. Astronomers immediately pointed every available radio dish they could toward the same patch of sky in the constellation Sagittarius, hoping, waiting for a repeat. They scanned that region again and again for months and then for years. They searched for any pattern, any modulation, any hint of a second message. But the silence was absolute. No echo, no follow-up, no further signal of any kind was ever detected from that precise location. It was as if the universe had spoken a single, perfect word directly to us and then refused to say another. This one-time nature is the core of the signal's enduring and chilling mystique, transforming it from a potential hello into a deeply ambiguous and haunting cosmic event. The implications of this singular, unrepeatable event are what truly send a shiver down the spine. One of the most unsettling possibilities is that we were not listening to a deliberate, sustained beacon, but rather intercepted a fleeting, one-time transmission that was never meant for us. Imagine an advanced civilization sending out a powerful burst of communication, a historical archive, a final declaration, or even a desperate distress call, aimed at one of their own colonies or spacecraft in a different star system. Our solar system and our primitive radio telescope simply happened to drift through the path of that message as it traversed the interstellar void. We were cosmic eavesdroppers, accidentally catching a fragment of a conversation not intended for our ears. In this scenario, the message itself is lost to us, an indecipherable data stream we recorded but cannot comprehend, and the civilization that sent it may have no idea we even heard it or may no longer exist to send another. This leads directly to the most sobering interpretation. The WOW signal could be a ghost, the last dying whisper of a civilization that has long since fallen silent. It takes centuries, even millennia, for radio waves to travel between the stars. The signal originated from a direction with no obvious nearby stars, but it could have come from hundreds or thousands of light years away. If that is the case, the beings who crafted and sent that powerful burst of radio energy could have been erased by the time it even reached Earth. They might have succumbed to any of the terrifying fates we've already explored: a gamma-ray burst, a technological apocalypse, or the slow creep of entropy. The WOW signal then becomes a cosmic obituary, a final testament to a people who once looked at their own stars with ambition and wonder, only to vanish, leaving behind this single, enigmatic artifact as proof that they were ever there at all. It is a poignant and frightening reminder of the potential transience of intelligence in the universe, a solitary data point that seems to whisper the grim warning of the Fermi paradox. The cosmos may be littered with the magnificent ruins of empires that briefly flickered into existence, shouted into the void, and were ultimately extinguished, leaving only echoes for us to accidentally stumble upon. From the haunting, one-time whisper of the wow signal, we turn to a threat of an entirely different scale, a slow-motion, cosmic demolition that has been unfolding for billions of years and is set to consume our own galactic home. At number 16, we confront the terrifying reality of galactic cannibalism. Far from being serene island universes, galaxies are dynamic and often violent structures engaged in a perpetual gravitational dance. Larger galaxies, through their immense gravitational influence, routinely tear apart and absorb smaller dwarf galaxies that venture too close. The evidence of this cosmic feast is written across the sky. Our own Milky Way is currently in the process of digesting several smaller galaxies, their stellar streams stretched into great, faint arcs around us like the lingering smoke from a celestial explosion. This is a fundamental process of galactic evolution, a cycle of creation and destruction on a scale that dwarfs all human history. But this isn't just a distant spectacle. It's a preview of our own galaxy's ultimate fate, because the Milky Way itself is not the predator in this story, it is the prey. The Great Devourer is our nearest major galactic neighbor, the Andromeda Galaxy. For decades, we viewed its beautiful spiral form with a sense of detached wonder, but precise measurements of its motion have revealed a chilling truth. Andromeda is not moving away from us. It is hurtling directly toward the Milky Way at a velocity of over 250,000 miles per hour. This isn't a possibility or a speculation. It is an inevitable future event, a cosmic collision scheduled to begin in approximately 4.5 billion years. When this happens, it will not be a simple, clean merger. It will be a chaotic, billion-year-long gravitational demolition derby that will utterly reshape both galaxies and scramble the fates of their hundreds of billions of stars. The familiar band of the Milky Way that has graced our night sky for all of human existence will be torn apart and remade into something entirely new. During the initial slow-motion collision, the sheer distances between stars mean direct stellar impacts are unlikely. The true danger lies in the invisible hand of gravity. As the two galaxies first sweep past each other, their mutual gravity will warp their beautiful spiral arms beyond recognition, stretching them into long, streaming tails of stars ejected into the intergalactic void. This first pass will be a preview of the chaos to come. The galaxies will then swing back like two pendulums in a cosmic clock for a second, more destructive encounter. This is when the gravitational turmoil will reach its peak. The orderly orbits of stars around their respective galactic centers will be thrown into disarray. Stars will be slingshotted in every direction, their trajectories altered by complex gravitational interactions in a process that astronomers call violent relaxation. Our own solar system, a tiny speck in this vastness, will be caught in the storm. This is where the threat becomes intensely personal. There exists a very real, statistically significant possibility that our Sun, along with its planetary system, could be ejected entirely from the newly forming galaxy. Imagine the scenario as the galactic cores of the Milky Way and Andromeda finally merge to form a new, giant elliptical galaxy, often nicknamed Milkdromeda. The gravitational slingshot effect could fling our star out into the profound darkness of intergalactic space. If this happens, the change from our perspective would be gradual but ultimately terrifying. Over millions of years, the night sky would transform. The dense, starry band of the Milky Way would fade, and the smudge of the Andromeda Galaxy would swell and then distort into a bizarre, misshapen glow before it too began to recede. The other stars in our new sky would slowly, one by one, wink out as we left them behind until we were left in a permanent, starless night. The only visible objects would be the faint, red-shifted ghosts of distant galaxies receding forever. Our solar system would become a true island, a lonely life raft adrift in an ocean of nothingness, with the nearest star potentially light years away in the empty void between galaxies. Even if we are fortunate enough to remain within the new galactic core, the environment there would be profoundly hostile. The merger will trigger a massive burst of new star formation as clouds of gas and dust collide and compress, lighting up the sky with the births of millions of new, brilliant but short-lived blue giant stars. These stars will burn fiercely and die young in spectacular supernova explosions. The rate of nearby supernova could increase dramatically, bathing any surviving planets in periodic waves of lethal radiation. Furthermore, the gravitational disruption could perturb the Oort cloud at the solar system's edge, sending a relentless shower of comets inward, pummeling any inner planets for eons. The serene, stable galactic neighborhood that allowed life to evolve on Earth will be gone, replaced by a brilliant, violent, and radioactive metropolis. Galactic cannibalism reveals that the cosmos is not a static painting but a dynamic and violent arena, and our place in it is temporary and precarious, subject to gravitational forces that can, in a cosmic instant, exile us from the stellar community forever or plunge us into a cauldron of celestial fire. After considering the ghost of a long-dead civilization in the WOW signal and the impending demolition of our galaxy, we now turn inward to a threat that is not external but foundational, questioning the very nature of our existence. At number 17, we confront a concept that has moved from the fringes of philosophy to a sober topic of scientific debate, the simulation hypothesis. This is the deeply unsettling idea that our universe, with all its vastness, history, and personal experience, is not the base level of reality, but an artificial construct, an immensely sophisticated simulation running on the computational substrate of a civilization vastly more advanced than our own. The argument, popularized by figures like philosopher Nick Bostrom, begins with a startlingly simple logical progression. If it is possible for a civilization to reach a technological level where it can create realistic, conscious simulations of its own history, and if such a civilization has even a modest interest in running these simulations for research or entertainment, then the number of simulated minds would quickly and vastly outnumber the number of original biological minds. Statistically speaking, if this is true, it is far more likely that we are living in one of those countless simulations than in the original, base reality. The implications of this being true are a Pandora's box of existential dread. The most immediate and chilling possibility is the concept of a shutdown. The universe we perceive, from the most distant quasar to the feeling of warmth on your skin, is, in this scenario, just data being processed. What happens when the experiment is over or the credits roll? The beings running the simulation could simply decide to pull the plug to cease the program. The end would not come with a bang or a whimper, but with the silent, instantaneous deletion of all that ever was or could be. One moment, a universe of trillions of galaxies and countless conscious lives, the next, nothing. It would be an erasure so complete it makes the heat death seem almost natural by comparison. There would be no warning, no appeal, and no legacy. Our entire struggle for meaning, our art, our love, our discoveries would be as ephemeral as a deleted spreadsheet. This leads to an even more personally disturbing thought, the nature of our own consciousness. Are we truly sentient, self-aware beings with free will? Or are we merely non-player characters, sophisticated algorithms programmed with the illusion of consciousness, following a script written by our unknowable creators? Our memories, our sense of self, our very internal monologue could be nothing more than pre-rendered backstory and reactive code. The profound moments of your life, your greatest joys and deepest sorrows, could be mere plot points or worse, random procedural generation designed to make the simulation more immersive for the true users watching from outside. This strips life of its intrinsic meaning and reduces our existence to a form of cosmic entertainment or academic exercise. The universe becomes a zoo, and we are the exhibits, unaware of the walls of our cage. Furthermore, the simulation hypothesis opens the door to even more terrifying sub-scenarios. What if the simulation is not a one-time, stable creation, but is instead riddled with bugs or subject to updates? Glitches in the fabric of reality could theoretically occur, from minor déjà vu to catastrophic violations of physics. An update could rewrite the laws of nature overnight, or simply decide that humans are no longer a necessary part of the program. Perhaps most frightening of all is the possibility of nested simulations. If an advanced civilization can create one realistic simulation, what is to stop the simulated beings within it from eventually developing their own technology and creating a simulation inside their simulation? We could be living in a simulation within a simulation, nested who knows how many layers deep, each step further removed from whatever real universe actually exists, making the truth forever inaccessible and our reality a pale, fragile copy of a copy. This hypothesis transforms the cosmos from a majestic arena of natural law into a potentially temporary and arbitrary digital creation, where our quest for understanding is ultimately just a process of reverse engineering the programming of gods we can never meet, leaving us to wonder if our reality is truly our own or merely someone else's virtual playground. Now, leaving behind the existential vertigo of simulated realities, we come to a threat that is both deeply personal and hauntingly cyclical, a horror that suggests our own sun may have a dark twin. At number 18, we explore the Nemesis star hypothesis, a theory proposing that our solar system is not a solitary star with its family of planets, but a binary system with our sun bound by gravity to a faint, unseen companion. This theoretical sibling is not a brilliant partner, but a dim, cool red dwarf or even a failed star known as a brown dwarf, orbiting so far out in the icy fringes of our system that it has remained undetected. This dark companion has been nicknamed Nemesis, and its proposed orbit is not a neat circle, but a long, flattened ellipse that takes it on a journey lasting millions of years. For most of its immense orbital period, Nemesis would be a distant, insignificant speck, but the terror lies in its periodic return, when its gravitational influence at its closest approach could stir up a storm of destruction from the solar system's deepest freezer. This hypothetical scenario focuses on the Oort cloud, a vast spherical shell of icy planetesimals that surrounds our solar system like a distant frozen moat. These trillions of cometary nuclei orbit in a fragile stability, so far from the sun that they are barely held by its gravity. The Nemesis theory posits that every 26 to 27 million years, as this dark star swings through its closest point to the sun, its gravity acts like a cosmic shepherd, perturbing the delicate orbits of countless Oort cloud objects. It doesn't take much. A slight gravitational nudge is all that's required to send a significant number of these icy bodies tumbling inward toward the heart of the solar system. This would initiate a heavy bombardment, a prolonged meteor shower on a planetary scale, with thousands of comets being diverted into paths that cross the orbits of the inner planets. For a world like Earth floating in the cosmic crossfire, the consequences would be apocalyptic. The evidence that gives this terrifying idea its chilling weight comes from our own planet's geological record. Paleontologists studying the history of life on Earth have identified a pattern of mass extinction events that appear to occur with a rough periodicity of about 26 million years. The most famous of these is the Cretaceous-Paleogene extinction that wiped out the dinosaurs 66 million years ago, an event widely attributed to a massive asteroid impact. But that catastrophe is just one data point in a longer, more ominous cycle. Other extinction boundaries in the fossil record, such as the late Devonian and the end Triassic events, also show signs of extraterrestrial impact, suggesting a recurring pattern of violence from the skies. The Nemesis hypothesis offers a compelling, if frightening, explanation for this grim timetable. It provides a celestial clockwork mechanism, a recurring trigger that could explain why, at regular intervals, life on Earth is subjected to a cataclysm from above. Of course, the search for Nemesis has been a long and ultimately fruitless one. Astronomers have conducted extensive sky surveys like the Wide Field Infrared Survey Explorer mission, specifically looking for a cool, distant object with the mass of a small star or a large planet. To date, no such object has been found. The vast distances and faint emissions of a cold brown dwarf make it an incredibly difficult target, but the consistent null results have led most of the scientific community to discount the original Nemesis theory. However, the underlying mystery of the periodic extinctions remains, prompting scientists to propose alternative, and in some ways even more unsettling, mechanisms that could produce the same effect without a stellar companion. One such alternative is that the Sun's journey around the Milky Way galaxy itself provides the timer. Our solar system does not orbit the galactic center in a flat plane. It bobs up and down through the dense galactic disk. This vertical oscillation has a period that roughly matches the extinction cycle. As we pass through the densest parts of the galactic plane, the increased gravitational influence from massive clouds of gas and dust, or even encounters with other stars, could perturb the Oort cloud in much the same way Nemesis was proposed to do. This galactic tide hypothesis removes the need for a local killer, but replaces it with a systemic one, implicating the very structure of our galaxy as the engine of periodic destruction. It suggests that our position in the Milky Way, the fundamental architecture of our cosmic home, inherently includes a built-in risk of comet showers every 26 million years. Whether the trigger is a dark sibling star or the rhythm of the galaxy itself, the core terror of the Nemesis hypothesis endures. It introduces the concept of a celestial predator we cannot see, a timer we cannot stop, and a cycle of violence written into the very fabric of our solar system's existence. It forces us to consider that the relative peace and stability we enjoy today may be nothing more than the calm between terrible, predictable storms. The dinosaurs, masters of the Earth for over 150 million years, were likely unaware of the cosmic clock counting down to their demise. The Nemesis theory, in all its forms, serves as a humbling reminder that our continued existence on this pale blue dot may depend as much on the empty, silent motions of distant, unseen bodies as it does on the fragile balance of our own biosphere. Emerging from the shadows of our own solar system's potential dangers, we now cast our gaze across truly cosmic distances to a phenomenon of such raw, staggering power that it dwarfs the energy output of entire galaxies. At number 19, we face the awesome and terrifying might of quasars. The name itself sounds like something from science fiction, but these are very real objects, and they represent the most persistently luminous and violent engines in the entire known universe. A quasar, short for quasi-stellar radio source, is the intensely bright core of a distant galaxy, a pinpoint of light that can outshine the combined output of its host galaxies' hundreds of billions of stars. This incredible luminosity doesn't come from stars, however. It is generated by a supermassive black hole, one with a mass millions or even billions of times that of our Sun, residing at the galaxy's heart. But a black hole alone is just a dark predator. A quasar is born when this monster is actively feeding. Vast quantities of gas, dust, and even entire stars are drawn into an incredibly hot, rapidly spinning accretion disk that spirals around the black hole. Friction and gravitational forces within this disk heat the material to millions of degrees, causing it to glow with a blinding intensity across the electromagnetic spectrum. This process is so efficient at converting mass to energy that it can outshine a galaxy, all from a region not much larger than our own solar system. The true signature of a quasar's destructive potential, however, is not this general glow, but its focused jets. Perpendicular to the accretion disk along the black hole's rotational axis, magnetic fields and intense radiation pressure can funnel a fraction of the infalling material into two narrow, opposing beams. These are not gentle streams of light. They are relativistic jets firing matter and energy outward at nearly the speed of light. These jets can extend for hundreds of thousands of light years, far beyond the boundaries of their host galaxy, acting like unimaginably powerful cosmic blowtorches. When these jets are pointed directly at our telescopes, we observe some of the most energetic phenomena in the cosmos, known as blazars. It is this narrow, focused nature of the jet that transforms a quasar from a brilliant cosmic lighthouse into a potential weapon of planetary annihilation on a scale we can barely comprehend. To understand the sheer destructive force of such a jet, you must first erase any notion of stellar comparisons. A single quasar's jet, when active and pointed in a specific direction, can carry more power than every star in its entire galaxy combined. Now imagine that this beam, this concentrated river of high-energy particles and radiation, were to swing across a planetary system. For any world caught in its path, the effect would be instant and absolute sterilization. There would be no gradual warming, no slow atmospheric erosion. The first wave of the jet's energy, primarily in the form of gamma rays and X-rays, would strike the planet's atmosphere with the force of a physical impact. This initial blast would ionize the upper atmosphere, ripping electrons from atoms and shredding the protective ozone layer in a flash. But that is merely the opening salvo. The main body of the jet, a torrent of protons and electrons accelerated to relativistic speeds, would arrive moments later. This particle storm would deliver a radiation dose so immense that it would not just kill all surface life, it would effectively erase the planet's biosphere. The very chemical building blocks of life, the complex organic molecules in every plant, animal, and microbe, would be shattered and broken down into their constituent atoms. The surface of the world would be scoured clean, baked under a torrent of energy that would make the surface of Venus seem temperate by comparison. The aftermath for such a planet would be a permanent state of death. The jet's passage might last for only a few years or decades, a mere blink in cosmic time, but the damage would be irreversible. The atmosphere would be left chemically transformed, possibly into a thick, opaque smog of nitrogen oxides, blocking sunlight and triggering a global winter that could last for millennia. The planet's magnetic field, if it had one, would be utterly overwhelmed, leaving the surface exposed to the full brunt of cosmic rays and the solar wind from its own star long after the quasar's jet has moved on. The world would be transformed from a vibrant, living world into a radioactive, airless rock. Its geology the only remaining testament to the life that once existed there. This is not an extinction event, it is a planetary reset button pushed with forces that operate on a galactic scale. What makes quasars particularly unsettling in the context of our cosmic safety is their prevalence in the universe's past. The peak era of quasar activity was billions of years ago, when the universe was younger, denser, and gas-rich galaxies provided ample fuel for their central black holes. While the nearest currently active quasar is now billions of light years away, posing no threat, their historical abundance suggests that such events have almost certainly occurred. Throughout cosmic history, countless planets orbiting stars in the path of a quasar's jet have likely been sterilized, their potential for life erased in a flash of energy from a distant, uncaring engine. This forces us to confront a chilling possibility that the great filter proposed by the Fermi paradox might not always be a civilization's own self-destruction, but could simply be a random, unlucky alignment with a galactic-scale force of nature. A species could be on the cusp of becoming spacefaring, looking up at the stars with wonder, only to have their entire sky blotted out by the approaching beam of a quasar they never knew existed, their civilization and their world unmade in an instant by a predator so vast it consumes galaxies. The quasar stands as the ultimate example of cosmic indifference, a reminder that the universe can produce engines of destruction so powerful that they can erase the potential of life across interstellar distances, all as a mere byproduct of a black hole's dinner. But from the sheer, observable power of a quasar, we now descend into a far more intimate and insidious form of terror, one that attacks not our planet, but our very perception of the past. At number 20, we encounter the unnerving enigma of the Mandela effect. You've almost certainly experienced this, or at least heard the famous examples. A large group of people distinctly remembers the children's book series being called The Berenstain Bears, yet the covers and all historical records show it was always spelled Berenstain. Others would swear on their lives that the evil queen in Disney's Snow White said, "Mirror, mirror on the wall," when the actual line is "magic mirror on the wall." And of course, the namesake of the phenomenon itself, countless individuals have vivid, detailed memories of news coverage reporting that Nelson Mandela died in prison during the 1980s, despite the historical fact that he was released, became president of South Africa, and died in 2013. These are not simple misrememberings, they are shared, specific, and deeply held false memories experienced by thousands, sometimes millions, of people independently. While psychologists offer conventional explanations centered on the malleability of human memory, how our brains reconstruct past events, filling in gaps with plausible details, and being influenced by suggestion, the sheer consistency and emotional conviction behind these collective false memories have led some to propose far more unsettling cosmic possibilities. What if the Mandela effect is not a glitch in our brains, but a glitch in reality itself? One of the most spine-chilling hypotheses is that we are not living in a single, stable timeline, but are instead occasionally shifting between closely parallel universes in a vast multiverse. In this model, every decision, every quantum event spawns a new branch of reality. Perhaps for reasons unknown, our collective consciousness or the fabric of our local reality sometimes slips from one branch to another that is almost identical, but with a few key, subtle differences. In the universe you originally came from, the bears were indeed the Berenstain Bears, and the Monopoly Man did have a monocle. But in this new, slightly altered branch you now inhabit, they never were. This idea transforms a quirky pop culture mystery into a profound existential horror. If this theory were true, it means that the bedrock of our shared experience, history itself, is not fixed. It is fluid and subject to change without our consent or even our awareness. The past you remember so clearly could be a relic from a universe that no longer exists for you. This erodes the very foundation of trust we have in our own minds and in the objective world around us. How can we be sure of anything? How can we trust our own memories, our own experiences, if they can be invalidated by a silent, imperceptible shift in the cosmic background? It creates a low-grade, persistent paranoia, a feeling that reality is a thin veneer and that at any moment you might discover another small, inexplicable crack in the world you thought you knew. An even more terrifying technological variant of this idea suggests that these inconsistencies are not natural slippages, but evidence of deliberate manipulation. If our universe is, as we discussed with the simulation hypothesis, a complex digital construct, then the Mandela effect could be the equivalent of software patches or data corruption. When the programmers update the base code of the simulation, they might inadvertently or intentionally alter minor details from the past. The old data is overwritten, and only the residual memories in our consciousness, like fragments of a deleted file, remain as evidence of the previous version. In this scenario, we are not shifting universes. Our universe is being edited around us, and we are the only ones who seem to notice the typos in the source code of existence. This introduces a layer of cosmic helplessness. We are passengers in a reality whose history can be rewritten by unseen administrators for purposes we cannot possibly comprehend. The ultimate fear the Mandela effect instills is a loss of epistemic certainty. When you can no longer trust your own recollection of fundamental facts, it destabilizes your sense of self and your connection to a shared human narrative. It creates a world where truth is negotiable and history is a moving target. This is a different kind of scare than a black hole or a gamma-ray burst. Those are external threats that could destroy our bodies. The Mandela effect, in its most horrifying interpretation, is a threat that destroys our confidence in the internal and external world, suggesting that the universe is not only stranger than we suppose, but that it might be actively gaslighting us on a global scale, leaving us to question every memory, every fact, and the very nature of the reality we all agree to inhabit. Moving from the unsettling thought of a dark stellar companion, we arrive at a tangible and ever-present reservoir of potential destruction, a frozen moat that silently guards the outer frontier of our own cosmic backyard. At number 21, we must acknowledge the Oort cloud. Far beyond the familiar orbits of the planets, far past the icy realm of the Kuiper belt where Pluto resides, lies this immense theoretical shell of primordial debris. It is the true boundary of our solar system, a vast and diffuse sphere of trillions of icy planetesimal rocky cores encased in frozen gases like ammonia, methane, and water, stretching from roughly 2,000 times the Earth-Sun distance out to a mind-numbing light year or more. To put that into perspective, while it takes light mere minutes to reach Earth from the Sun, it would take that same light an entire year to travel from the Sun to the outer edge of this cloud. This makes the Oort cloud not just a distant feature, but the single largest structure in our solar system, a colossal, unseen halo of frozen potential. The sheer number of objects within this cloud is what transforms it from a simple curiosity into a source of profound unease. Each of these trillions of icy bodies is a potential long-period comet, a dormant worldlet waiting for a gravitational nudge to send it falling sunward. Because they are so distant, small, and dark, we have never directly observed a single object in the Oort cloud. Its existence is inferred from the orbits of the comets that occasionally plunge into the inner solar system from every conceivable direction. These comets, with orbital periods measured in thousands or even millions of years, originate from this deep freeze. They are the messengers from this silent, outer darkness, and their appearance is a constant reminder of the unimaginable number of icy bullets stocked in this cosmic arsenal, any one of which could have our name on it. The true terror of the Oort cloud lies in its profound instability. These objects orbit at such immense distances that the Sun's gravitational grip is incredibly weak, more of a gentle suggestion than a firm command. This delicate balance makes the entire cloud exquisitely sensitive to external gravitational influences. The primary trigger for sending these icy nomads on a death dive toward the inner planets is the gentle, persistent tug of the galactic tide, the combined gravity of the billions of stars that make up the disk of our Milky Way galaxy. But a far more dramatic and dangerous perturbation can come from a chance encounter with a passing star. Our Sun, along with its entire entourage of planets and this vast cloud of comets, is constantly moving through the galaxy. Every few million years, another star drifts relatively close within a light year or two of our solar system. When such a stellar interloper passes by, its gravity acts like a cosmic shepherd's staff poking into the delicate structure of the Oort cloud. It doesn't take a direct hit or a massive collision. The mere passage of a star like Scariest or Alpha Centauri at a distance of 1 trillion miles would be enough to stir this frozen nest. The gravitational perturbation from the passerby can alter the orbits of countless Oort cloud objects, robbing some of just enough orbital energy to send them tumbling inward toward the warmth of the Sun. This process effectively loads a celestial gun, setting in motion a cascade of comets that will begin a journey lasting hundreds of thousands of years before they ever reach the inner solar system. The star that triggered this event would be long gone, having continued its journey across the galaxy, leaving behind an invisible legacy of destruction that will not manifest for millennia. Consider the trajectory of just one of these long-period comets, set on its new path by such a stellar passage. Its journey from the outermost darkness is a slow, patient fall. For eons, it travels through the near-absolute zero void, a frozen, primordial relic from the solar system's birth. As it finally approaches the realm of the planets, the sun's warmth begins to act upon it, vaporizing its frozen gases and unleashing a magnificent, glowing coma and a tail that can stretch across millions of miles of space. From our perspective, it appears as a beautiful, once-in-a-civilization spectacle in the night sky. But this beauty is a lethal mirage. The comet's nucleus, a mountain of ice and rock, is now a projectile moving at tremendous speed through the crowded inner solar system. The threat it poses is identical to that of a massive asteroid, but with one crucial difference. Its extreme orbit means we would have very little warning. Unlike asteroids whose orbits we can map and predict, a long-period comet coming from the Oort cloud can appear from any direction with only a few months or years of notice, giving us precious little time to prepare or deflect it. This scenario is not merely theoretical. It is a recurring feature of our solar system's history and a plausible explanation for some of Earth's past mass extinctions. While the impact that doomed the dinosaurs is widely attributed to an asteroid from the inner belt, the geological record suggests that Earth has also been subjected to periods of heavy cometary bombardment. A close stellar pass could trigger not just one, but a shower of these objects, a storm of comets raining down on the inner planets for tens of thousands of years. The environmental effects of a single large comet impact are apocalyptic. Global firestorms, an impact winter lasting for years from ejected dust blocking sunlight, and the acidification of the oceans. A sustained shower would keep the planet in a perpetual state of trauma, collapsing food webs and making recovery between impacts impossible. The Oort cloud, therefore, represents a constant, low probability but existential threat. It is a frozen sword of Damocles hanging over our entire civilization, its string pulled not by our own actions, but by the random, silent motions of the stars in our galactic neighborhood, a reminder that even the most distant and seemingly separate parts of our cosmic home are intricately linked in a dance that can, without warning, bring death from the deepest cold. The objects we've discussed so far have been cosmic phenomena, exploding stars, dark matter, and sprawling voids. But what if the scariest thing in deep space isn't an impersonal force of nature, but a deliberate, silent watcher, one that has been floating right above us for centuries, perhaps even millennia? This brings us to number 22 on our list, the unnerving and enduring legend of the Black Knight satellite. This isn't a story confirmed by science, but a conspiracy theory so pervasive and compelling that it taps directly into our deepest fears of not being alone, and worse, of being the subjects of a silent, unacknowledged observation. The core of the myth is that an alien probe of immense age and unknown purpose is in a near-polar orbit around Earth, a piece of extraterrestrial technology that has been watching our world since long before we ever launched Sputnik. The idea that we could be under the constant, unblinking gaze of an intelligence so advanced it makes our own technology seem primitive is a uniquely intimate form of cosmic dread. The so-called evidence for the Black Knight is a patchwork of misunderstood events and misidentified objects, which somehow makes the legend more unsettling as it thrives in the gaps of our own knowledge. One of the most cited pieces of the puzzle dates back to the late 19th century, with reports from Nikola Tesla, who claimed to have intercepted strange, repeating radio signals that he believed could be an attempt at communication from another world. Decades later, in the 1920s, amateur radio operators began reporting long-delayed echoes, where their own transmitted signals would return to them seconds later, as if bounced off something in space. Then, in the 1960s, both the United States and the Soviet Union reported tracking a mysterious, dark object in an unusual orbit. This was the era of the space race, and the sudden, official acknowledgement of an unidentified satellite caused a global stir. The most famous image associated with the Black Knight was captured during a 1998 Space Shuttle Endeavour mission, appearing to show a dark, irregular object against the backdrop of Earth, which proponents immediately hailed as photographic proof. Of course, there are perfectly logical explanations for each of these phenomena. The object tracked in the 60s was almost certainly a piece of space debris, perhaps a discarded thermal blanket or a piece of a rocket body tumbling in an odd orbit. The famous shuttle photo has been identified by NASA as a lost thermal blanket that came loose during an earlier spacewalk. The radio signals and echoes can be attributed to natural astrophysical phenomena or early technical glitches. Skeptics have thoroughly debunked the individual components of the myth, yet it persists with a stubborn resilience. This persistence is the true source of the legend's power. The human mind is a pattern recognition engine, and when faced with a series of unexplained events, it will often weave them into a single, coherent narrative, even if that narrative is terrifying. The idea of a hidden observer satisfies a deep-seated psychological need for there to be a reason behind the random noise of the universe. The most chilling interpretation of the Black Knight theory, however, is not that it's a hoax, but that it might be real and that its purpose is entirely inscrutable. If such a probe were in orbit, its technology would be so far beyond our comprehension that we might not even recognize it as artificial. It could be constructed from metamaterials that absorb all radar and light, making it effectively invisible to our senses. Its power source could be something we haven't even discovered yet, like a microscopic black hole or a dark matter reactor, allowing it to operate for eons without refueling. What would its mission be? Is it a silent sentinel programmed to observe a developing civilization without interference, a principle akin to the prime directive in science fiction? Or is it something more ominous, a Trojan horse, waiting for a specific technological or genetic trigger within humanity before it activates? Perhaps it's a galactic archive, a backup of a long-dead civilization's knowledge, waiting for us to reach a level of sophistication where we can access it without destroying ourselves with the information. This leads to the ultimate, unsettling question posed by the Black Knight legend. What if we are not the creators of our destiny, but merely specimens in a cosmic experiment? The notion that our entire history, our wars, our art, our ascent from the savannah to the stars has been quietly monitored and recorded by an unseen presence is a profound assault on our sense of agency. It transforms our planet from a sovereign world into a zoo or a laboratory. Every major human achievement could be just a data point in a vast alien database. This is a different kind of fear than the imminent destruction of a gamma-ray burst. This is a slow-burning psychological horror, the fear of being a subject rather than a citizen of the universe. The enduring mystery of the Black Knight satellite, whether fact or fiction, forces us to confront the possibility that the greatest threats may not always come from the cold, indifferent cosmos, but from the intelligent, patient, and utterly silent eyes that might be watching us from just beyond our atmosphere. Yet after all these terrors, the invisible predators, the ghostly signals, and the silent watchers, we arrive at perhaps the most intellectually haunting concept of all, one that transforms the silent, starry sky into a canvas for our deepest existential anxieties. At number 23, we must confront the chilling implications of the Drake equation and its terrifying shadow, the Great Filter. Conceived by astronomer Frank Drake in the 1960s, this equation is not meant to provide a single, definitive answer, but rather to frame the probabilities involved in a single, profound question. How many communicative civilizations might currently exist in our galaxy? The equation itself is a cascade of variables multiplying factors like the rate of star formation, the fraction of stars with planets, the number of planets in a habitable zone, the fraction where life actually appears, the fraction where life becomes intelligent, and finally, the agonizingly crucial variable, L, the average lifetime of a technologically communicative civilization. Plug in optimistic numbers and the galaxy should be a bustling, noisy metropolis. But the observable silence, the very paradox we explored earlier, screams that at least one of these terms must be catastrophically small. This is where the great filter theory emerges, not as part of the equation itself, but as the terrifying explanation for why its final answer seems to be nearly zero. The great filter is the hypothesized barrier, a critical developmental step that is so improbably difficult to pass that it effectively prevents life from progressing to the stage of becoming a visible, interstellar civilization. The sheer, gut-wrenching terror of this idea lies in a simple, brutal either/or scenario. Either this filter is behind us or it is ahead of us. There is no comfortable middle ground. If the filter is in our past, it means that humanity has already, against astronomical odds, passed through a near impossible bottleneck. Perhaps the origin of life itself from non-living chemistry was the incredible fluke, a 1 in a trillion event per galaxy. Or maybe the jump from simple prokaryotic cells to complex eukaryotic cells, a transition that took over 1 billion years on Earth, is the true bottleneck. If this is the case, we are not just lucky, we are cosmically unique, the first and only species in the Milky Way to have crossed this profound threshold. The silence of the cosmos in this scenario is a sign of our profound solitude, a universe of empty habitable worlds waiting for us to inherit them. This is the hopeful yet strangely lonely interpretation. The alternative, however, is the stuff of genuine nightmares. If the great filter is ahead of us, then the silence we hear is not one of emptiness, but one of graveyards. This interpretation suggests that the path from our current level of technological adolescence to a mature, enduring, star-faring civilization is littered with existential traps that no species can avoid. We are not special, we are simply next in line. The filter, in this case, would be the reason we see no other civilizations, because every single one that has reached our stage of development has been wiped out shortly thereafter. This transforms the cosmos from a frontier of hope into a cosmic shooting gallery where technological intelligence is a brightly flashing beacon that inevitably attracts the bullet of self-destruction. The frightening plausibility of this is that we can already see the potential filters materializing in our own world. The discovery of atomic energy granted us the power to obliterate our global civilization in an afternoon. Advances in synthetic biology could accidentally or intentionally unleash a genetically engineered pandemic with a near 100% fatality rate. The dawn of artificial intelligence presents the risk of creating an entity whose goals are misaligned with our own survival, leading to our swift and efficient replacement. In this view, the technological progress we celebrate may be nothing more than a race to build the tools of our own extinction, but the potential filters are not only of our own making. Looking outward introduces even more chilling possibilities. The universe itself might be inherently dangerous in ways we are only beginning to understand. We've already discussed gamma-ray bursts and rogue black holes, but what if the galaxy is home to a recurring, natural cleansing mechanism? Perhaps every few million years, the solar system passes through a dense interstellar cloud that triggers a global ice age so severe it resets complex life. Or maybe the galactic center periodically emits pulses of deadly radiation during periods of intense activity, sterilizing a large portion of the galaxy's spiral arms. An even more unnerving hypothesis is that the universe is not empty but policed. The dark forest solution to the Fermi paradox suggests that the cosmos is filled with civilizations that have learned the ultimate survival strategy: stay hidden. In a dark forest, any hunter who reveals their location is quickly eliminated by a more powerful hunter fearful of competition. In such a universe, the first and only law is to remain silent. Any civilization foolish enough to broadcast its existence, as we have with our television and radio signals for the past century, is signing its own death warrant. Our attempts to search for friends could be what summons the executioner, a hyper-advanced civilization that systematically exterminates potential rivals before they can become a threat. This places humanity in a position of unbearable cosmic suspense. We are like a student who has passed every grade with flying colors, only to be told that the final exam has a 99.9% failure rate, and we are walking into the testing room now. Every day we avoid nuclear war. Every year we contain a deadly virus. Every moment our nascent artificial intelligence systems do not turn against us. We are not proving our resilience, but merely delaying the inevitable. Or are we? The truly terrifying part is that we have no way of knowing which scenario is true. We are living through the experiment, and the data won't be clear until we either collapse into ruin or somehow manage to burst through into the galactic community. The Drake equation, therefore, is more than a thought experiment. It is a mirror held up to our species. It forces us to ask whether our intelligence and technological prowess are the keys to a boundless future or a perfectly engineered self-destruct mechanism. The profound fear it instills is not of a specific monster, but of a statistical probability, a silent, invisible wall in the road of evolution that we are either miraculously on the right side of, or are speeding toward at an ever-increasing velocity. Leaving behind the statistical dread of the Great Filter, we now arrive at a horror that is not about the death of civilization, but about the theft of time itself. At number 24, we confront the cold, unforgiving reality of time dilation, a consequence of Einstein's theory of relativity that transforms the dream of interstellar travel into a potential nightmare of absolute, irreversible isolation. The theory itself is a cornerstone of modern physics, stating that the passage of time is not a universal constant ticking away at the same rate for everyone, everywhere. Instead, time is relative and its flow is intrinsically linked to both velocity and gravity. The faster you move through space, the slower your clock ticks relative to a stationary observer. This isn't a mechanical error or a perceptual illusion. It is a fundamental property of the universe, confirmed by incredibly precise experiments with atomic clocks on fast-moving jets and orbiting satellites. For the purpose of space travel, this means that an astronaut on a spacecraft approaching the speed of light would experience time passing at a much slower rate than the people they left behind on Earth. A journey that feels like a mere decade for the crew could span centuries, millennia, or even entire epochs back home. Imagine a dedicated crew embarking on humanity's first voyage to a nearby star system like Proxima Centauri, just over 4 light-years away. With a revolutionary propulsion system allowing them to travel at 90% the speed of light, the one-way trip from their perspective might take just a few years. They would live their lives aboard the ship, conducting research, maintaining systems, and watching their destination grow closer. After a successful mission, they would turn their ship around and begin the journey home, another few years of their lives passing by. When they finally re-enter Earth's orbit, only 8 or 9 years will have passed for them. But due to the relentless math of time dilation, over 20 years will have elapsed on Earth. They would return to a world where their young children are now middle-aged, their parents are likely gone, and the cultural and technological landscape has shifted in ways they can scarcely recognize. This alone is a profound psychological burden, a form of temporal exile. But this is merely the gentlest, most merciful version of the horror. Now amplify the scenario. Consider a more ambitious mission to a star 1,000 light-years away. To make the voyage feasible within a human lifetime, the ship would need to travel at an astounding 99.9% of the speed of light. For the crew, the journey there and back might take a manageable 40 years. They would leave as young adults and return in their old age, having spent their entire working lives on this grand endeavor. But when their ship decelerates and establishes communication with Earth, they would make a devastating discovery. While 40 years passed for them, over 2,000 years have passed on their home planet. The world they knew is gone, not just transformed, but utterly erased by the march of time. Every single person they ever knew or loved has been dead for centuries. The nations they pledged allegiance to have crumbled into dust. Their languages are now dead tongues studied by archaeologists, and their entire culture is a forgotten footnote in a history book. They are living fossils, anthropological curiosities in a society that would be as alien to them as an advanced extraterrestrial civilization. Their heroic return is not a homecoming, it is an archaeological dig into their own graves. This transforms the cosmic explorer from a pioneer into the ultimate orphan, a figure of profound and permanent loneliness. There is no going back, no way to reverse the relativistic effects. They have effectively traveled into the future, but it is a one-way ticket with no possibility of return. The connections that root a human being to the world family, friends, shared memories, a sense of belonging are all severed by the impersonal equations of physics. The crew would be utterly disconnected, their personal histories meaningless to the new inhabitants of Earth. They might be studied, interviewed, and placed in a museum, but they could never truly integrate. The psychological impact of this is unimaginable. It is a solitude so complete it transcends mere physical isolation. They are alone not in space, but in time, stranded on the distant shore of an era they were never meant to see. The terror deepens when we consider the ultimate hypothetical journey. Push the velocity infinitely closer to the speed of light, and the time dilation effect becomes almost godlike in its power. A ship accelerating for what feels like a few decades of shipboard time could theoretically cross the entire 100,000 light-year breadth of the Milky Way. But upon their arrival back in the vicinity of Earth, the crew would find that not thousands, but hundreds of thousands of years had passed. They would be returning to a post-human world, a planet where humanity had either evolved into something unrecognizable, transcended to a non-biological form, or had simply vanished entirely. The Earth itself might be cold and silent, its oceans frozen and its atmosphere thinned, with the last remnants of human cities buried under layers of ice and sediment. In this extreme scenario, the astronauts become the last of their kind, the sole living witnesses to a species and a world that time has forgotten. Their mission, their lives, and their very memories become the final, fading echo of a civilization that blinked out of existence eons ago. Time dilation, therefore, reveals a chilling paradox at the heart of space exploration. The very laws of physics that might one day allow us to reach for the stars also contain the mechanism for our most profound and personal loss, severing our most sacred connection to home and history, and leaving us as ghosts in the machine of a future we can never call our own. We have journeyed together through a gallery of cosmic horrors, from the silent, drifting menace of rogue planets to the ultimate, chilling silence of the Fermi paradox. We have faced the phantom pull of the Great Attractor, the potential for reality itself to unravel through vacuum decay, and the patient, cyclical threat of a dark stellar twin. We have witnessed the explosive ends promised by gamma-ray bursts and zombie stars, and the slow, crushing grip of supermassive black holes. We have contemplated the psychological terror of the Mandela effect, the technological trap of Kessler syndrome, and the existential prison of quantum immortality. We have peered into the profound emptiness of the Boötes void, felt the ominous whisper of the WOW signal, and acknowledged the frozen arsenal of our own Oort cloud. We have seen the universe's engines of violence in quasars and pulsars, grappled with the invisible dominance of dark matter, and trembled at the ultimate fates of the Big Rip and the cosmic heat death. We have considered the possibility of silent watchers in the Black Knight legend, the statistical dread of the Great Filter, and the personal exile mandated by time dilation. And we have stood before the ultimate predator, the invisible and unstoppable rogue black hole. This journey has taken us from the familiar confines of our solar system to the very edge of physics and beyond, into realms where the rules we depend on simply cease to apply. What unites these 25 terrors, from the galactic scale of cannibalism to the quantum scale of reality shifts, is a single, humbling theme: our profound fragility and our even more profound ignorance. We are temporary residents on a tiny, rocky world, adrift in a cosmos that is, for the most part, utterly indifferent to our existence. The forces that shape the universe operate on scales of time and space that dwarf human history and comprehension. A gamma-ray burst that could erase all life is simply the death rattle of a star. A vacuum decay event that could rewrite physics is just a field settling into a lower energy state. There is no malice in these actions, only the cold, impartial execution of natural law. This indifference is perhaps more terrifying than any directed evil, for it means our survival is not a matter of cosmic justice or merit, but of sheer statistical luck. We are living on borrowed time in a very dangerous neighborhood, yet this realization is not a cause for despair, but for a profound and sobering perspective. Understanding these terrifying possibilities does not diminish our world. It makes the fragile beauty of our existence all the more precious. The stable orbit of our planet, the protective shield of our atmosphere, the steady glow of our sun, these are not universal constants. They are rare and fortunate gifts in a cosmos that is more often characterized by violence, emptiness, and mystery. Every time we look up at a peaceful, starry night, we are witnessing a fleeting moment of calm in a storm of cosmic activity, a temporary haven in an overwhelming ocean of potential dangers and bewildering enigmas. This knowledge grants us a unique responsibility to cherish our world, to nurture our civilization, and to continue looking upward with a blend of courage, curiosity, and a deep, respectful awe for the unknown. Now, this journey through the abyss is yours to continue. We have walked through this gallery of cosmic fear together, but I want to hear which of these 25 concepts truly resonated with you on a deeper level. Did the silent, stalking nature of the rogue black hole instill a primal dread? Did the philosophical implications of the simulation hypothesis or quantum immortality keep you up at night, questioning the nature of your own reality? Or was it the slow, grinding inevitability of the heat death that you found most existentially unsettling? Share your thoughts and your personal number 1 scare in the comments below. I read every single one and love to see these discussions unfold. If you found this exploration of the universe's darkest mysteries compelling, then you won't want to miss what comes next. Make sure to subscribe to the channel and hit the notification bell, because we are only just beginning to scratch the surface of the unknown. From the secrets of black hole interiors to the mind-bending possibilities of the multiverse, our journey into the deepest wonders and terrors of the cosmos is far from over.